Moving on to the next one, magnetic field Lorentz force. As we know that only the moving charges are producing magnetic field. If it is static, it will not produce any magnetic field. So what is Lorentz force? When a moving object is placed in both field means both electric field as well as magnetic field. So the moving particles is under in electric field and magnetic field. Both field are acting on that moving particle, right? Here the particle means charge we are going to take. And due to that magnetic field and electric field, there is a magnetic force as well as electric force is developed in that charge particles, that charge, that we are saying that Lorentz force here, right? Okay, now moving on to the topic. A point charge Q is moving with a velocity v and located r at a given time t in the presence of both electric field E vector is a function of r and the magnetic field vector B vector in the function of r. So here I wrote. Then the force on the electric charge is expressed as F vector is equal to Q into E vector function of r plus V vector into B vector into r. That is equivalent to, so Q into E, that will gives electric force. Q into V into B, that will gives magnetic force, right? So be clear with that. So this is we have this V is also vector quantity only. Okay. So Q into E is the force due to electric field. Q into V into B of R, that is magnetic field. The force which is developed by due to magnetic field. Now we are concentrating on this F is called, we are saying that Lorentz force. The combination of both electric field and magnetic field, we are saying that Lorentz force. The magnetic force, what is magnetic force? Q into V into B of R. That magnetic force depends upon Q, charge, and V, the velocity, moving velocity, and the magnetic field, right? And the magnetic force on the negative charge is just opposite to the positive charge. Yes, because the sign changes are there, therefore the magnetic force also in the opposite direction. As in that for positive direction, it will be, the force will be like that, right? But similarly for negative force, negative charge, the force will be acting in the opposite direction. So these two are in opposite direction, right? So the magnetic force on a negative charge is opposite to that positive charge. And the second one, the magnetic force Q. The magnetic force QV of R is a vector product, right? QV of R is a vector product. This is vector product. Only this V and B is vector product. How we can write? It's the vector product of velocity and magnetic field. This is velocity, this is magnetic field. So we can write the Q bracket V into B of R. This is vector product. Vector. So this V is also vector, B is also vector. So vector product, right? Velocity as well as magnetic field. So we can write this vector product as QV B of R sin theta n cap. Whenever the cross product comes, we need to use sin theta. If we have dot product, that time we are going to use cos theta. This is a general rule in physics part, right? For vector product, we are going to use sin theta. For dot product, instead of cross product, right? We will use dot product. For the dot product, we should use cos theta, right? And listen here, this velocity, the charge particle moving with the velocity, right? That should be perpendicular to magnetic field. Why? Because here we have sin theta, right? Perpendicular means 90 degree. So whenever, if velocity and this magnetic field is 90 degree, then only the magnetic force is developed, right? Suppose if it is not 90 degree, as in that 0 degree or 180 degree, that is called parallel and anti-parallel. That time there is no magnetic force is developed. Because sin 0 is 0, sin 180 is also 0, right? And we can write the magnetic field B is equal to F divided by QV. So what is the SI unit of magnetic field? Tesla. How to define 1 Tesla? 1 Newton of force is acting on 1 coulomb of charge which has velocity of 1 meter per second. The developed magnetic field is 1 Tesla. Again I am telling you how to define 1 Tesla. 1 Newton of force is acting on 1 coulomb of charge. That charge is moving with a velocity of 1 meter per second. Then the magnetic field is, we are saying that 1 Tesla. So this is Tesla, SI unit for magnetic field, right? And the magnetic force is 0 when if the velocity and magnetic field are parallel and anti-parallel. I said right. So when sine 0 is 0, sine 180 is also 0. Sorry, not 1, 0. Okay. If it is 0, the entire term will be 0. There is no magnetic force. And magnetic force is 0 if V is 0. That's we know about, because only the moving charges are producing magnetism, right? So if it is not moving means V becomes 0. So static charges never create magnetism, right? So this will be 0. And one more thing I want to tell you here. Cos. What is cos? This is a small unit of magnetic field. 1 cos is equal to 10 to the power minus 4 Tesla. This is very small unit, but it is not SI unit. Very small unit of magnetic field we are measuring, right? I hope you understand well. Thank you and see you in the next video.